recall that solutions are things mixed together, but there is no reaction. You mix them together, but they don't react. It's a form of a mixture. It's a homogeneous mixture. And why things dissolve has to do with forces of attraction, or lack thereof, actually. Why does water and salt mix together? Because of the polarity of water being polar, and then, like say, salt having positive and negative charges. So that's why things dissolve. And you learn that there's different types of solutions. You could have a mixture, a solution that would be a solid liquid one, salt water. Or you could have one that's a gas liquid. Now, I want to focus on this right here, a gas dissolved in a liquid. This is sort of a weird deal. Gases dissolved in liquids. Now, and you think about this from an attractive perspective, we could say dissolve oxygen in water. But you might have just learned a little bit ago that oxygen is nonpolar, water is polar, and yet we're saying, does oxygen dissolve in water? Well, actually it does. And it's very important, like for the case of this right here. You've seen those bubblers that happen inside of an aquarium. Why is that? That's because in the aquarium, if you have a fishy, right, he needs to breathe oxygen. He's got gills. He needs to breathe oxygen just like you. So I get breath. I'm bringing in oxygen, my cells use it, but there's no oxygen in the water, right? Wrong. There's actually dissolved little particles of oxygen. That's why you have the bubbler, is to get that water, get that oxygen dissolved in it, so that when it hits his gill, he can extract the oxygen from using his gill system, I'm not a biologist, to then burn it up inside of his cells so he can survive. So there is gases that are dissolved in water. Very, very fascinating. Now when we talk about solutions, there's actually 3 kinds of solutions, but let's cut to a video to explain 2 of the types. So when we talk about solutions, remember a solution is a homogeneous mixture of 2 substances. Oftentimes they are of different states of matter. So for example, I have a simple beaker of water, or glass jar of water, and some salt. And if I were to mix a little bit of salt in the water, as you are well aware, you do this all the time. This happens in your mouth when you say, for example, have a French fry. It dissolves in the saliva in your mouth, and of course you taste the salt. And so now if you look at this, all the salt is dissolved, and I have a clear solution, a homogeneous mixture of water and salt. Now, since all of the salt dissolves, we call this a unsaturated solution, when all of it, or some of it, doesn't dissolve. But if you think about it for a moment, I could add more salt. All right. Now, if I added more salt and I were to taste this, it would taste saltier. But if I mix it all up more, it all dissolves again, and I have another clear solution. But can't you envision a point where if I ever add more salt, and like more salt, and like more salt, and like more salt, I'd reach a point where it's going to taste really, really nasty, super salty. But the other thing that you're going to notice is that if you look at the bottom, you'll see at the bottom there is some salt at the bottom of the container. So there's a point where the water can't dissolve the salt. And I could put 10 pounds of salt in here, or whatever. However much it can hold, that is what we call a saturated solution, where the water, in this case, can't dissolve any more salt. Now, it turns out the solubility is a number. Let's take it up there next. So you say we've got those saturated solutions, we've got unsaturated. Remember, unsaturated, where you're not less than the maximum, right? And this is the maximum. And if we have time and if I can get it to work, I really want us to learn that there is a 3rd type, and that is called a supersaturated. Now, this is a weird one where there's actually more than the maximum. Isn't that an oxymoron? More than the maximum? Can you have more than you can actually have? And the answer is yes. Because actually for something to form, you can actually, well, tell you what, we'll try and do this in class, and it's so much easier to see what it looks like if we could see it in action. So there is something called supersaturated solutions, and they're like super duper way cool. And the last thing we're talking about today is the effect of temperature on solubility. Because the temperature, particularly now talking about aqueous solutions or solutions with a liquid, is what happens to chemicals as you raise the temperature of the solvent, in this case usually water. So I've got a beaker filled with water, and if I have it, on a hot plate, how much can dissolve in different situations? Well, it turns out there's really two different trends. So if I dissolve a solid, like the salt we saw just a little bit ago, if I take the salt and I dissolve it in hot water versus cold water, what do you think? Can I dissolve more salt in hot water than cold water? Or sugar, or whatever it might be? Well, as it turns out, here's a graph right here, and this graph indicates that the higher the temperature in general, there's not always the case, higher the temperature, the more solid can dissolve in a substance. You've known this, right? If you've ever taken sugar, you can dissolve a lot more sugar in water, in hot water, than you can in cold water. But what about, let's go back to gases. Instead of this being a solid, what if this was a gas? Let's think about this for a moment. So if I take the gases, they're dissolved in the water, right? They're tiny little gas particles, not very attracted, and then I turn the heat up, what do you think will happen? Well, you're right. This is what happens. It's actually always the case. With a gas, the higher the temperature, the less the gas can happen. In fact, this is actually a problem for fish. Back to our fish. We talked about fish earlier, right? If I've got a fish, all right, let's put a fish in here. If I got a fish living in here and we heat the water up, what happens to all the oxygen, the gases? They leave. And what happens to the fish? He'll die. Not just because the water's hot, but because there's not enough oxygen for him to breathe. This is actually a problem in some near industrial plants. They'll pump some hot water into the lakes and streams. They call that thermal pollution. And what it does is it takes the gas out and it can kill the fish because they will suffocate, literally, because there's no dissolved oxygen in the water. And I said there was a last thing, but I forgot to say there is one last thing. Let's talk about solubility one last thing. One last thing about solubility is that it's a number. We saw the numbers in the graphs that we saw. They're over here now. The graphs. And the number is almost always, well, 1 unit, I should say. It's the grams of solute per 100 grams of solvent. There's other ways to measure it, and you'll learn about that later on, how we measure the solubility. Now, when you think about, this is when we're measuring at the saturation, and that's what these graphs over here represent, is based on temperature and whatnot. And we can measure this, and then we can actually determine interesting questions. And you're going to do a worksheet in class that's going to help you to understand how to use these graphs here with this to solve the problem. In class, we're going to play around with gas solubility and do a very interesting experiment in class to help us understand. And lastly, let me say one more thing about solutions and these properties of solutions. There are really three types of, if you will, solutions. Well, if you will, there's a solution, there's a colloid. We're going to focus on solutions as a whole unit. And then there's something called a suspension. Now, these different types of mixtures have to do with particle size. Where solutions are super duper small, like really small, colloids are medium in size, and you can probably figure out that suspensions are large. In fact, how small? This is 10 to the minus 7th centimeters or smaller. This is 10 to the minus 7th to 10 to the minus 5th centimeters, and these will be greater than 10 to the minus 5th centimeters. Now, it turns out when you have solutions, colloids, and suspensions, something intriguing happens. If you pass light through a solution, right? So if I got a solution, a clear solution, it could be red or green or whatever, let's say pink or whatever color you've got here. If you pass light through, it goes straight through. In a colloid, it reflects light, and in a suspension, it also reflects light. You can see the light passing through. Like, look at these images right here, and you can see how it goes goes through the solution, and then the colloid is different. Now the thing about a suspension is that if you let it sit, it will settle. That's how you spell settle, but settle, S-E-T-T-E-L, L-E. It'll settle down, and it's a suspension, and it will settle to the bottom. So 3 types, and that's the last bit here on the properties of solution.